for debugging the process flow, for process flow, and also for teaching, for use in courses as well. It's a great learning tool for the students to learn about MEMS processing and all of the that are involved with that. So without further ado, I'm going to jump in and start talking about the Intellifab process. And what I'm going to do today is pretty much just show some of the features and some of the tools of how the program is used. And then at the end, we'll have some time for questions. But so I'm going to go ahead and jump right in and start talking about the Intellifab program. You should be able to see on your screen what the basic program looks like. And basically how you use the program is that we have a built-in material and process database that we've compiled since 1991. So over 20 years, we've been boundaries and we've found ourselves for a long period of time, and we've done a lot of MEMS processing work ourselves. So we have lots of experience and expertise in the area of MEMS processing. So we have our material and process database included, as I mentioned, and this is where we can be choosing the different process steps, and eventually we're going to be building up a virtual process traveler. So you'll see over here on the left-hand side of your screen is what the process database looks like. And so simply to build up your process traveler, you're going to be choosing different steps from the process database. So most likely we would start our process flow with some kind of definition of a silicon wafer. And so we would just double click on any of the process steps over here in the process database, and that would add them into our process traveler that we're going to be building up here on the right side of the window. And you'll see that we've defined our first step, which is a silicon wafer definition with 100 orientation. And you'll see for when we add the process step into the traveler, you'll see that the process properties are listed over here now on the left-hand side of the window. And for each process step that you add into the traveler, you can set up some of the different process parameters for that process step. And so in this case, the most important thing that we would be defining this step is the thickness of our silicon wafer. And so that we would just input that value right here. Looks like it's set up to be 50 microns right now. So to build up your process traveler, you're going to go ahead and continue choosing from the process database and building things up. You'll see there's a wide array of materials that you can be then depositing on top of this silicon wafer. So say we might have silicon nitride layer that we're going to be depositing. And we have the option, in most cases, we're going to set it up as a conformal deposition. We have the option to set that up, or we can set up a planarization step or a non-conformal deposition step. We can choose to deposit the material on the top side or on the bottom side or both sides. And then say we go ahead and input the thickness of the layer again there. And so now I did mention that that we had a built-in material database and process database, and that we can access by choosing this open MEMS button right here. And MEMS is the name of our material database. So when we go ahead and open up that material database, you'll see that this is all of the material data that we have for that silicon nitride step. And from various foundry partners and various sources that we've worked with, we have a lot of different experimental data about this specific process step. And what we can do within the material database is that we can look at how changes in the process parameters are going to affect the material properties in that specific material as it undergoes that process step. So we can look at some of these different process parameters. We can say if we are going to be running this process at a different temperature, say 250 degrees Celsius, rather than 275, we can change that value and you'll see that it's going to make a change to the material properties that you see here in the upper left. So based on the experimental data that we have, as I showed you kind of down in the bottom here, it will extrapolate the changes in the material properties that that's going to cause. And what we can do is, even as we can look at a different curve and we can say view a 2D curve of, say, how changes in the temperature of that process step is going to affect the residual stress in the material. Or we can even look at two variables and say how changing the temperature and the pressure is going to affect residual stress. So you see we get this 3D curve with changes in temperature on the x-axis here, changes in pressure of the process step on the y-axis, and then you'll see we get the 3D graph of the residual stress. So then we're going to go and continue building up our process flow. As the next step, we may maybe deposit some photoresist in our process traveler here. And after we deposit some photoresist, we might want to be doing a lithography step. So this might be this lithography step here that we might define. And then the next step would be to link our process flow with our mask file that we have generated with our mask layout file. And to do that, we're just simply going to select the mask layout file that we have. And within Intellisuite, we can import many standard mask layout formats. We can import GDS formats, or we can import DXF or some other formats as well. But for the most part, if you're using some other standard format like GDS or DXF, it's very easy to import those and open those up in Intellisuite. Or you could also use, we also have a layout tool called Blueprint as well that's included within the Intellisuite, that's included with the Intellifab program that you could use as well. And if we have time at the end, I might be able to go ahead and open that up and talk a little bit more about the layout editor. But if not, that might be a topic for a future webinar in the coming months. So once we open our mask file, what we can do is, if we want to look at the whole mask file, we can do that, or if we just want to look at a small portion of the mask file, we can just do, it's a little bit faint, but there's an outline of the mask file that you can see in this preview window, and you can just drag this box around the area that you want to look at, area of the mask file that you want to look at. Or if you know the specific coordinates in the mask file that you want to use, that you want to view, you can input those here. So that links our mask file in with this process flow, and then if we have any lithography steps in the parameter setup for that lithography step, we can just select the mask layer that we want to reference at that step. And so you'll see in this specific layout file, there's only one layer, but say you have a layout file with multiple layers, 10 or 15 layers, they would all be listed here for you to select from. And then after we do a lithography step, we might want to have an etching step after that. And so there's various etching steps that can be done, which I'll talk a little bit more about later. So that's the way that we're going to go ahead and be building up our process flow. And right now I'm going to go ahead and open up an example process flow that's already been built up for us. You'll see this is just a short 8-step process flow, and this is a corner compensation example that deals with wet etching of silicon. You'll see we have this mask preview here, and this pink structure is the mask layer that we're going to be applying on. This is a compensation example for wet etching of silicon. And so I'll just go ahead and open that up. So you'll see that when we build up the process flow, then the next thing that we're going to want to do is visualize the process flow that we've built up here. And so the visualization tool that we most likely use is called FabSim, which is our the visualization part of the software. So we would just click that button, and then we would go ahead and be able to open up the model in FabSim. And so then you should be able to see that the visualization opens up on your screen here. And what we can do then is we can just go ahead and run through the process flow and see what it looks like. So we'll just click this play button to run the process flow. And you'll see that it'll visualize the full structure. Okay, sorry, I was just having some technical difficulties on our side here, but I think we're ready to go now. So you'll see that we ran through the process flow to get an idea of what the structure looks like, and then once we've run through everything, there's a couple different options that we have. We can look at cross-sections of the structure, and sometimes this is useful if we have a very complex process flow with which is hard to see the whole thing. In this case, it's just kind of a simple etch of a silicon wafer, but you'll see this is what the cross-section capability looks like, and it's very easy to just be dragging these cross-sections, and you can rotate them, rotate the cross-sections kind of any which way you'd like in order to get a better idea of how the structure looks inside. And what you can also do is you can go ahead and you can export a PowerPoint file of the process sequence, or you can export a video animation of an animation of the simulator running through each of the process steps, or you can just export simple image files. And the one advantage of our tool Intellifab is that it's a full process simulation tool, as opposed to just a visualization tool. A lot of the other MEMS tools on the market are kind of more of a simple geometric approximation. But the advantage of Intellifab is that we're really the leader in MEMS process simulation tools, and so we have capability to do full process simulation. And what that means is that in this case we're doing a wet etch of silicon, and you'll see that it actually has the correct behavior that you would see in the silicon wet etching. So if we go back and look at this mask layer that we defined on the silicon wafer, you'll see that it has these corner compensation features. And when we're actually looking at the simulation, you'll see that there's the undercutting that you're going to see in a wet etch. And this is something that's really unique to IntelliSuite. This is not something that you'll be able to do anywhere else, is do accurate simulations like this. And what you can even do is in the wet etching step, you can edit these process parameters. So you can say you can change the for this TMAH step, you can change the concentration of the etchants, or you can change the etch time, or you can change the temperature that you're running it at. And changing those parameters is going to give you a different result in the geometry. So we're not limited to just having to define all the geometry in your process flow. You're actually able to do some some physical simulation here. And another area where this is useful is, I'll just open up another example. So what this is a dry etching step on silicon. You'll see in this process flow, it's pretty simple. We've just got a silicon wafer defined. You apply some photoresist on it and have a lithography step of a certain mask shape. And then we're just going to do a DRIE etch on the silicon. And so you'll see this example here is we've got our silicon wafer defined, and we're just going to put that photoresist on top, and you'll see etch out this shape. What we're going to be looking at here is the etch lag for the dry etch. And then we're going to etch in the silicon. And so if you use that cross-section tool to go ahead and look at a cross-section of the wafer, you'll see that it's actually going to model different phenomena like the etch lag. You'll see that these larger holes are going to be etched more quickly than the smaller holes. And if we were to turn the resolution up, we could even look at some of the sidewall scalloping and some of the other phenomena that are present with a DRIE etch or with the Bosch process. So that's another very useful part of Intellifab when you are really debugging a process flow or developing a process flow or kind of wanting to show students how some of these different wet etching phenomena or dry etching phenomena or different MEMS process steps like that, kind of show them a little bit about how these different process steps work. And so if I go back into Intellifab, we've looked at a couple simple examples here. I'll just go ahead and open up one little bit more complex example. Now, within the tool, we have several different process design kits included. And so these are standard processes like maybe the MEMS process from MEMSCAP or the Summit process from Sandia, the Screen process out of Cornell, or we've got, say, like the Texas Instruments micromirror array. A lot of the standard processes are included within IntelliSuite, and so within those processes, you'll see this example is an example of the MEMS process. We have the whole process flow built up already, and we have a design rule deck that you can do a design rule check on the layout. And really all you need to do is load in the mask file, and everything's pretty much ready to go. So that's a very, very useful thing for for showing students and using for teaching, talking about some of these different standard processes, and also if you're using one of those, if you're fabricating a device using one of those processes, very easy to just open up the template here and have everything ready to go already. And so you'll see this is the MEMS process that's been built up, and you'll see there's a couple different options that we have here. You can see you can create groups for grouping different process steps together. If you have a more complex process flow like this, you can use this filtering tool and say, type in the step that you want to look at, and it'll just show you, show you only the steps that you filter for. And there's lots of different other things that you can do as far as, say, if you wanted to group your process into the different material types, there's different ways of sorting and organizing the process flow. One other thing you can do is when you have the process flow all built up, you can export this process traveler to Microsoft Excel. And so this will automatically generate for you an Excel file You'll see if I share Microsoft Excel here, this is the process traveler that gets generated automatically by the program. And you'll see for each process step it has some of the different process parameters that were set up. And so this is something useful that can be taken into the clean room, and you can go ahead and make notes on this document if you want, and go and share this with different people in the organization. But so now that we have our whole MEMS process built up, what we can do is go ahead and visualize it again. We visualize it in FabSim. FabSim is the visualization side of things. And then so you'll see the visualization of the process being built up. You'll see the different material layers being deposited and the different etches being done. And you'll see the whole device being built up. And you'll see that this is running through very quickly. So this is where we can really save a lot of time, preventing people or eliminating the need for having to go into the clean room and run multiple iterations in there. You'll see if you want to make changes to this process flow, you could just do that very quickly and then go ahead and run the visualization again in just a couple seconds, which is going to save a lot of time versus having to go and manufacture this whole device all again. And so in this case, this was the MEMS process, and it was a thermal actuator that was built up. And so we already talked a little bit about the cross sections, but this is another area where you might want to go and be looking at cross sections in the device. But kind of the final thing, as I was talking about sharing the Excel file between people in the organization, what we can do is if we generate a PowerPoint file, that's something very useful that you can go ahead and use as well in different presentations and in sending between people. And so you'll see I just opened up PowerPoint, Microsoft PowerPoint, and this file gets automatically generated. So there's no work that you have to do as a user in making this file. This will get automatically generated, and it will have a individual slide for each process step. You'll see it lists the name of the process step here, along with some of the process parameters. And you can also say if you wanted to go ahead and make notes in here, you can you can go ahead and make notes on here. And so this is this is a very useful feature. Because say if you're presenting the results from your work or something like that, you can go ahead and incorporate these slides right into the presentation that you have. And in addition to the slide for each process step, we've got a summary slides at the end, which group together, in this case, all the lithography steps, all the depositions are grouped together, and all the etch steps are grouped together. That's just useful for organizing things. So that's one other tool that you can use is the PowerPoint export. PowerPoint exports, video animation, as I mentioned. We'll show you, have an AVI clip of that simulator running through the whole process flow. And obviously, I won't talk too much about now, but it's it's possible to play with the resolution settings for this model. So, say if you wanted a really high quality image, you could turn up the resolution settings. But that's not really something that needs to be talked about too much right now. So that's some of the main aspects of the visualization. Finally, when you've developed the process flow as you're liking, you can then go ahead and export. You can export this model to for use in a finite element simulator. And so this is something that just can be exported right here from Intellifab. And it's going to go through our Hexpresso meshing engine. And this is where you can set up the mesh size that you'd like to have for the structure. You can actually, if you want to get really advanced, you can simulate a small misalignment for one of your layers, your mask layers. You can see how that would affect the final structure. If it's going to be slightly misaligned or rotated, one of the masks. As you're creating your mesh, you can choose if you have a certain area on your structure that you need to have a more fine mesh. You can just drag that box and input the mesh size that you'd like to have around that certain part of the structure. So that's very useful for really optimizing your mesh of the structure. You can do that in the SY direction, or you can do that in the Z direction as well. So if there's one certain layer that you want to have a more fine mesh on, you can split it up more finely. And then you'll just go ahead and exporting this as a mesh, which can then be used within our Intellisuite multi-physics simulator, or we can also export many standard 3D formats, such as IGES or SAT or ANSYS formats or PATRAM neutral formats. Many different types of 3D solid model and 3D mesh formats. And if you're using the Intellisuite, it's very easy to define your material properties right here within Intellifab. So for each of the materials that we're using, we can define what the material properties are. and have those exported right over to our multi-physics simulator, making it very easy for things to get set up. So that makes it very easy to look at some analyses. Say you want to look at the residual stress in a layer, or you want to do something else like that. It's very easy to export this model here from Intellifab, so you can go and look at some of those different things. So the other thing that I haven't really mentioned so far was just going back to the process database. We do have a pretty large database that's included within the software here, but it's also possible to add in new process steps. And to do that, you would simply put this database into the edit mode, and say if you had a new material that you want to deposit, you could just add a new material, and then you'll see it would create this new setting where you could name the material and put in some of the process parameters and properties that you wanted associated with that step. And that's something that's easy to do. So it's always possible to add in new steps, and if you were using the software, that's something that our support engineers would be happy to help you out with, importing new process steps into the simulator. And then once you have the database edited, you could go ahead and save that database, so then all of your new process steps and materials would be accessible for you. And with that, I think that's about everything that I had planned to talk about with Intellifab today. So as you'll recall, we talked a little bit about actually building the process flow here within Intellifab, and using the material database to look at the different materials that were included. We also linked our mask file, our mask layout, into the process flow here, which allowed us to go and do the visualization. And then along with the visualization, we looked at different cross-sections and different ways to manipulate the model within the visualization tool, as well as exporting to Excel and PowerPoint and video clips and image files. And then you'll see too that there's also a lot of capability for adding in your own process steps. But really, once again, to repeat, is that really Intellifab is the most powerful tool out there when it comes to MEMS process simulation, because there's really no other tool that has the capability for the full simulation like we have, and full simulation of the wet etching and the dry etching and different steps like that. So in addition to the visualization, and then you'll remember we also talked about exporting to a mesh format for then further analysis on the structure. But even if you're not exporting to a finite element tool, Intellifab is very useful in and of itself, just for the quick visualization of the MEMS process, which, as I mentioned before, is very helpful, as opposed to going back and forth to the clean room multiple times, as well as the software can be used, as I mentioned, for teaching as well, showing students some of the basic aspects of the MEMS process flow, and some of the basic behavior, and just kind of how processing is done in the MEMS industry. And so with that, I guess I'll go ahead and turn it back over, and I'll be happy to take any questions that any of the attendees have.